They need to
try to
just
help
go
out
click.
if anybody has any ability to do that. I don't know. If you think of them, let me know. But can you hear me? Do I need the microphone? Can you hear me in the back? Okay. Okay, so again, I'm Lisa Williams. I'm with Old Line Environmental. We're owned by Synagro, and we are basically a contractor that manages biosolids for a lot of the municipalities. So we take the biosolids from a lot of the treatment plants here in Maryland, and we manage them and basically land apply, or we make products that we sell that are distributed throughout the state, either in bulk or maybe through some of the local home and garden stores, etc. And I like to show this picture just because this is a great picture for me, because we get a lot of questions about biosolids all the time. You know, do they run off? Do they this? Are they going to get into my stream, into my well? Because again, as you saw Jerry's presentation, there's a lot of regulations. We've got buffers, we can't put on slopes, we've got to maintain pH, all these kind of things, stay away from property lines, you know, wells, etc. And this picture is a great picture of a pasture that was spread with biosolids, as you can see. Pretty square, nice squares in the middle of this field. So you can see exactly where biosolids were applied. You know, we stayed away from that drainage swale in the middle, the property line with the fence. And you're not seeing little fingers coming off of that in green where stuff really ran off. So I mean, biosolids are sticky. You know, they're just like manures as well. They kind of, when you put them there, they tend to stay right where you put them. They're not coming off too far unless for some reason we've got some incredible, crazy weather events, which again, we do get some of those. But you know, 99% of the time, biosolids are staying where you put them, just like manures do. Anyway, so jump into the next thing. Oh, I guess I've got it up here. I'm sitting here.
You've got one if it works.
Should be.
Can I do it with this?
Mm-hmm.
Oh,
Yeah, there we go.
All right, I'm over here thinking you're going, and I see it landing. So let's just start off with, what is biosolids? So biosolids basically is the solids and the organic matter that's basically generated throughout the different processes at a wastewater treatment plant. So basically you've got several segments in the wastewater plant. All the treatment goes on to clean the water, to make sure we get clean water going back into our streams and rivers. All the solids get moved out of that plant, end up going to like an area in the facility that basically gets treated, stabilized, treated for the pathogen reduction, vector attraction reduction, the things that Jerry talked about that are required in the regs. And those become ultimately, in our world, we call them biosolids. They're not sludge anymore. They've been treated to a product that ultimately becomes beneficial for recycling. So that's basically what biosolids are. And so I like to just kind of give it a quick overview of wastewater treatment. This is basically the meat of everything we do. So this is an aerial shot. Of course, it's an old one again, of the Blue Plains wastewater treatment plant in DC. Again, Blue Plains is like one of the biggest wastewater plants in the country. If they're not one, they're two anyway, but they're basically manage about 300 million gallons of wastewater a day. And they actually, this is an older plant, so they used to do a Class B lime state, and all their material was land applied on site-specific farms, and they managed about 1,000 tons of material a day coming out of there. In the last few years, they upgraded to Class A, so Jerry, we talked about the different treatments, pathogen reduction. So they make a product now that basically is a Class A that can be distributed in the home and garden stores, can be processed and just taken out and given to farmers, so they sell some. And they also upgraded so that they have stormwater flows and things like that also goes into the thing. They built a huge tunnel. So their now overflows can manage 1 billion gallons of wastewater a day. It's a huge place, making a lot of material. But I wanted to kind of start with wastewater, because again, we talked about what are biosolids, and they basically come from a wastewater plant. So let's just talk about wastewater treatment. I don't know how many people have been to a plant or even understand the biosolids, but it's a pretty cool process. You know, basically a wastewater treatment plant is really a facility that's been designed to mimic and then speed up basically what happens like in natural water purification. So how a stream works. It cleans itself naturally. Well, a wastewater treatment plant is designed to do that just quickly with more volume. So basically you've got on the front end of the plant material coming in. So you've got all your raw sewage, wastewater coming in from sewage, bathrooms, wastewater, wash facilities, runoff, whatever's coming into the plant. The front end of the plant, which is not necessarily shown on here, but typically they have things called R streams, and they basically collect all the nasty large stuff. So you're getting, you know, rags and plastics, grit, and all the large things that come in, get kind of pulled off, they go into a dumpster, end up going to the landfill. Then the next phase is really primary treatment. Again, the wastewater treatment plant, again, as I said, mimics kind of the natural cleaning process. So it's basically a combination of physical, chemical, and biological processes going on in the plant. The first phase, primary, really is solids come in after the large things are removed. There's still some heavy sands and particles and grit still in there. So it goes to a big circular primary tank, and the solids still kind of just fall out. It's basically a physical separation. It sits in those tanks for long enough that the solids fall to the bottom, little thing skims across the top, takes off stuff, and the water flows over to the next phase. So again, down the bottom, all the solids end up going into a big tank at the plant that ends up getting processed later for the biosolids, depending on what process they use. But at different stages of the plant, the solids that continually get removed from the process end up flowing to the solids handling part of the plant and are managed and then become the biosolids that we then take out and put on farm fuels or make products. So once it leaves that primary tank, solids go to the sludge part of the plant, water goes over the weirs, ends up to the next phase. And again, it's sort of the meat of the wastewater plant. It's basically the aeration, they call it activated waste kind of section, kind of right before a primary, secondary, or right before a secondary clarifier. This is the heart of the plant. So they basically have the microorganisms and things that are in the plant come in. That's the wastewater coming in is the food. So the treatment plant kind of makes microorganisms. They keep them in this waste activated system. They aerate it so it gets the right amount of air. They return solids so that it's got more food and more microorganisms. The new wastewater coming in is feeding. It's just an ongoing cycle, and they basically try to manage that to the best that the microbes are basically eating and cleaning the wastewater. So once you get to secondary, it's kind of like a primary tank, similar in the way it works. Now that it's gone through this aeration and oxidation kind of cleaning set, it goes to the tanks, settles again, more solids come off, go to the sludge, clean water goes over the top. And then we have advanced treatment. And again, in today's world, everybody's now at wastewater plants are required to manage nutrients, even more than they were before. So all the requirements to discharge from a treatment plant into the bay means there's more nitrogen and more phosphorus removal. So a lot of this happens chemically. We're doing some, iron addition or ferric of some sort, or alum where you're going to remove phosphorus. A lot of the biological processes get advanced and they do a sort of an anoxic, aerobic, anaerobic, that's more of a nitrification, denitrification, so they remove more nitrogen from the thing. But again, for us in the biosolids world, the water's getting cleaner, so it goes out, that means the biosolids are getting more nutrients, which, depending on how you look at it, is good and bad. So at the end, once all the processes in the wastewater plant happen, all the solids fall to the end, it gets to the end in a place in the plant that, is the solids management part of the plant, and those become the biosolids at some point, depending on what stabilization process they use. Most folks use dewatering anymore. What dewatering means is that the solids that are kind of liquid that went through the plant are all in tanks. They kind of squeeze the water out either with a belt filter press or a centrifuge, so that contractors like us are hauling out more of a drier product than just liquid, because it's less cost, less material to move. So moving that is easier. So Jerry kind of touched on this in his presentation, but I'll go through it a little bit real quick again. So for us to manage the biosolids, you have to meet either one of two processes. And again, in Maryland, they follow the 5030 EPA rules. So basically, to meet Class B, which is a process to significantly reduce pathogens. So this is equivalent kind of to the A, protection of health, that where we have to do another process. But we meet this by all those site restrictions that Jerry mentioned. Remember, we've got buffers, and you can't grow crops for a certain amount of years, and we've got, public access and pH has to stay at 6. So to meet Class B, you basically have to meet some of these processes. And these are, he listed a couple others, but these are really the three common that are used mostly in Maryland. So you've got kind of aerobic digestion. Again, they basically have it in a tank. It's being digested, and what the digest means is basically it's sitting in there, basically being maintained at a particular temperature for a certain amount of days with air. It's aerobic. Anaerobic, it's the same process, but there's no air in the system. And again, these two processes basically, again, are biological. So different organisms grow in the aerobic tank as the ones that grow in the anaerobic tank. Basically, different things thrive, but they all ultimately reduce the organic matter, break down the material, stabilize it, reduce the pathogens. So this process, these Class B PSRP, Class A, are all to remove pathogens from the solids. So these are the three. And then lime stabilization is basically where they're basically adding lime. And so they add enough lime to the solids to raise the pH to 12. And basically you have to maintain the pH 12 for 2 hours for pathogen control, and they make sure that it's still 11.5 by the next day, and that actually meets their vector. But these are the Class B processes. And when you have a Class B product, it has to go out on a permitted site. Each farm is permitted to use Class B, and the biosolid sources that we use are all approved by MDE on their list of approved sources. So then if we go to A, same thing. Some of the plants do B, some of the plants do A. It costs more to do A. You know, it's more processes, it's more expense to build the facilities. But again, A means it's been further processed. And the material, typically these are some of the common things. Composting, you make a pellet out of a dryer with thermal drying. Pasteurization is basically they meet a temperature for a certain amount of time. Thermophilic digestion is just a digestion with a little bit more pressure and heat, higher temperatures. But all of these end up meeting the pathogen reduction requirements for A. And again, A as a PFRP, further reducing pathogens, means this product, you know, we can bag it and sell it at Home Depot or Lowe's or whatever. You can go buy this. The problem is most of the generators that make A, they have so much volume on a given day that, you know, you'd be making 1,000 bags a day at the plant to try to get rid of. So most of this goes out in bulk. You know, so they're selling it to landscapers, home and garden places, and then they bag it and sell it. Or they're, you know, farmers are using it depending on what that is, and they may buy it and we bring it out and however that works. But so there's basically these combinations. Just remember A and B are for pathogen reduction, and these are treatment processes at the plant. This process, you do not need that site-specific permit that I talked about for B. The person making this, though, whoever that treatment plant is, or if we're the contractor doing it for them, we have to have a permit that allows us to make that product and then distribute it. So it's sort of a distribution and marketing permit for an A product versus a site-specific land application permit for a B product. And then again, why are we doing this? Well, keep in mind, I mean, wastewater treatment, you know, is key to maintaining our public health. If we don't have a wastewater treatment plant, we're going to be a really sick community. So, you know, wastewater treatment is key to us staying healthy. So basically, and it's the ultimate recycling. And again, keep in mind, wastewater treatment, you know, it doesn't stop because it's Christmas or a holiday or whatever. It doesn't stop in a pandemic. Everybody's flushing every single day, no matter what's going on. So in order for that treatment plant to do what it needs to do to clean that water, meaning, you know, running through the process, recycling solids have to leave the plant pretty regularly. And again, most plants are moving out, you know, we're moving material from them, you know, 6 days a week, you know, Monday through Saturday. Typically Sunday we kind of hold it till Monday. But again, all of the program is really basically set up to basically benefit from the recycling. You know, all the regulations and the treatment and pathogen reduction and so forth are there to protect public health. The buffers and the treatment of the material is there to protect groundwater and surface water. And then also we need something reliable. Like I said, stuff's coming every day from every treatment plant across the country, across the world. Every day, you know, materials being made. So we need some kind of a reliable outlet. And the way this program works, as most of you aren't really sure, from our side, from the Synagro Old Line side, the contractor perspective, we get paid from the treatment plant. So we manage the product from the treatment plants. So typically, on our Class B program, we give these products away to the farmer. As long as they're willing to sign up, go through the permitting process, wait for us to get the permit, and then when they do have a permit, kind of wait for us to get to them. Again, we might, you know, they got a 100-acre farm, we got 30 loads, it'll do 10 acres today. It's going to take us a little bit, and we got farmer A, B, and C before we get to him. It's sort of a logistics scheduling nightmare, but basically that's how come we give it away. Because we can't get there when they want it. We can't necessarily always get to them every year, but we know that we'll work through the program. So the farmers that participate in the Class B program get the material for free. And again, what are the benefits? As you see, through the wastewater process, the solids are getting more and more, you know, it's high in nitrogen, it's high in phosphorus, and a lot of micronutrients. It's very, you know, nutrient rich. Again, it's high in organic matter, just like manures. You know, so using this material is going to increase, you know, your cation exchange, your water holding capacity, till. And again, if the treatment plant used lime, for instance, in that lime stabilization for class B processing, then you'll get the benefit of getting lime added to your field if you need it. And I did this from last year. I did not update this year, so this is probably through the roof because I was afraid to look at the fertilizer prices. All I've seen is we're getting more calls this year. Can we get to people this year than we have in forever? And there's still just so much, you know, although I said there's, you know, flushing every day and volumes are coming, it's still limited. I can't get everywhere every day. But, you know, just the nutrient aspect of this from, you know, looking at if I was going to fertilize a farmer's field and we're going to grow 125 bushels of corn. So let's say basically this is based on giving them 125 pounds of nitrogen for that crop. You know, just the nutrient level, we're at 140, 150. You know, if we have lime, we've got that in there. So it's over $200. And this was last year's numbers when I calculated this. I'm not, honestly, I don't know where we are this year on nitrogen fertilizer. I know it's through the roof. So as you can see, it's a benefit, even though we may not get to them every year, the years that we can, you know, this is a big savings per acre, you know, a lot. So, and again, some of those requirements, you know, the pH of the field, before we can apply, again, I'm kind of talking from a management perspective, how we manage this. You know, we have to still abide by the rules. We still have to fit into the farmer's program, get out there when crops are coming on, getting ready to go on and off. But the field pH has to be at 6 before we apply. We've got to check it twice a year to make sure that if we have applied that field, that it stays at 6. Again, these are all the Class B requirements for a site-specific permit. A does not require this. Lime state, though, again, you know, you can put too much lime out there. So we're also requiring that if the field is already too high, we can't apply any more lime. If that field is up to 7.5, it can't receive any lime anymore. So it's kind of caps you at both ends and make sure you stay kind of in the middle. And then I just want to throw in some pictures to kind of give you an idea of what it looks like. So again, this is basically a dewatered Class B cake coming out to the farm field. You know, it's basically, when I say dewatered, most of the Class B cake is 25% solids. So that means it's still 75% water, but it looks pretty dry versus, you know, again, a liquid. So it can be hauled in a dump trailer. It doesn't, you know, it's got seals and tarps, but it's not like it's a liquid sealed container. Basically, it's unloaded right in the middle of the field where we're going to apply. Obviously, from a Class B permitted site, we've got to be right in that field. So we're applying it, you know, unloading it right in the permitted area. Just a couple shots just to get the feel. Again, it's just like a regular manure application. We're picking it up with a front end loader. After we've unloaded it, we're putting it in a manure type spreader. We're pulling it with a farm tractor, spreading it across the field based on the nutrient management plan that we wrote for the farm. Just a couple other pictures, multiple trucks unloading different materials, keep it going. And then for the Class B program, if we are applying on a farm that is not HEL or no-till or hay or pasture, then at the end of the day, we have to incorporate. So just keep that in mind from the regulations. So we're spreading. In the summer, we tend to do a lot of mine, sand and gravel kind of operations. Again, think about how we got to manage our business. Biosolids are coming every day. Spring crop window is about ready to close here soon. We're pretty much about finishing up corn here. We've got a few more weeks because it's been a little wet and cold. So it's kind of a little longer than it has been. But, you know, we might get a little bit of soybeans in. But again, the soybeans capped at 50 pounds is all we can put. So it's really a low rate. It's really hard to put that down without going 90 miles an hour across the field with a farm tractor and a box trying to put only 50 pounds down. So we don't really do much soybean ground. So once the corn ground is done, we kind of got to look for other things. So then we start moving into hay, pasture. And summer we do a lot of sand and gravel things. So the way the mining programs work, these operations kind of mine the sand and gravel out, take the good stuff that they want, and they backfill it with whatever they've got left over that's not so good soil. And then as part of their permit under the mining program, they're required to put it back to certain grade and then vegetate it and keep it vegetated. So when they put really crappy soils and all the not so good stuff back in there, it's really hard to grow. So we do a reclamation rate on these, and typically we're getting these vegetated, and then once they get them vegetated with biosolids, they can keep them, and then they get their bonds released and all this kind of thing. So it's a great program from the mining perspective. So this also allows us, to kind of go from the spring crop window to the summer window, kind of into fall some things, and then winter we're sort of storing and going to other states. But again, we're applying and incorporating pretty much shortly thereafter. Just quick again, there aren't that many folks doing liquid anymore, but if they are, it's being hauled obviously in a tanker, a sealed tanker. It comes out to the field and it's liquid. It's basically being transferred literally from like a vacuum hose right to a liquid application vehicle. Again, everybody's moving the cake. I can't even think of a liquid generator anymore. And basically, again, obviously none of this gets dumped on the field, not like the cake box is unloading it right onto the field. This is being transferred right to the vehicle. Then that thing would inject it right into the soil. Obviously, we're applying to a field that's going to get planted in something because it's going to get tilled up. Obviously, we're injecting and tilling it up. You can also, like I mentioned, at the end of the day, we have to disc it unless it's a hay field, hay field pasture, some kind of crop existing, or no-till, or a highly erodible land. And then just another quick picture of liquid. This is a different application vehicle, but this allows us to spray on top instead of injecting. So it's got more of a pan and the thing to spray the liquid across if you want to do a pasture or something, a surface application. All right, so let's get to the meat of how we figure this stuff out from a nutrient management standpoint. So from our end, we did biosolids data. And I tried to just kind of give you a couple sources that gave you an A, a digest, a B, a lime, an aerobic, just so you could kind of get the feel for what the data looks like. It's kind of all over the place. From solids are all over the place to, nitrogen is definitely varies. In the middle there, you'll see sort of Cox Creek and Parkway. Those are the two, one in the lime state. I see Matter Woman as well. But again, you see the TKN values are a little lower than the others. And again, just keep in mind when we add that high pH quick lime calcium oxide to the sludge, it basically reacts as a big heat reaction and you get a lot of volatilization. So we actually lose nitrogen when you add the lime to the mix. So it actually reduces some of the nitrogen. So I wanted to just give you a feel, but we look at basically our lab data. Make sure your lab data that you're getting comes out. It's all in dry weight. Make sure you're not looking at as received or wet weight, but your lab data comes out in a dry weight analysis. And I kind of highlighted these in the greens and yellows, so when you get to the next slides, you'll know where I pulled those numbers from to do the next calculations. It was just easy for you to kind of follow it, to go back and see where I got it from. But so we've got raw data. This is literally right off of my analysis. So now I need to figure out again, from MDE, the way things work is they put out a PAN table. And that PAN is the plant available nitrogen. And they actually tell us what every biosolid source that's approved to be used in Maryland, what the nitrogen is, what the PAN is, what the phosphorus, blah, 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 that we can use for the year. And now this is not necessarily what's on that table, but this is how you get those numbers. So they tell us how we can use those. And so for us in our permits, so for instance, if we have a farm that needs 100 pounds of nitrogen, for instance, to fulfill its fertilization requirement, MDE gives us all those PAN numbers. So let's just say, for instance, Matter Woman's PAN was 25. So it's 25 pounds of nitrogen per dry ton. So if I need 100, I'm going to divide by 25, I need 4 dry tons. So all of our permits and all of our analytical data and all the stuff we have to manage on paper is in dry tons. So we're going to take these numbers and we're going to convert it to pounds per dry ton. So I took my data straight from the lab analytical, which is the previous sheet. And so I just did 2 examples here so you could kind of see 2 different ones. So the Blue Plains Class A, I want to convert that TKN now. It came right off on my sheet from the lab. That basically said it was 5.08. Again, I did that in yellow on the previous sheet. So if I want to calculate the pounds per dry ton, I basically take the percent of that concentration, so in this point, TKN, as a decimal, so that 5.8 divided by 100, so 0.058 times 2,000. And that is literally the pounds per dry ton of that nutrient in that biosolids source. So for Blue Plains digested Class A, it's 101 pounds of TKN per dry ton of that material. When I look at sod run, did the same calculation. It had 4.39% TKN off of the lab data. As a decimal times 2,000, it has 87.8 pounds per dry ton. And I did all the same calculations for ammonia, organic nitrogen. Now, quick thing of note too, TKN minus ammonia equals organic N, just if you need a quick organic number from your lab data. So from here, okay, so now all my permits, all my regs, everything that says all the lab data is in pounds per dry ton, everything's in dry weight, everything. But when it comes to me in the field, it's not dry, it's wet. It's exactly what's made at the plant. It's 30% solids, it's 20% solids, it's 17. It's not 101 pounds in dry ton because I don't get a dry ton, I get the wet ton. So now we're gonna take pounds per dry ton and I'm gonna convert it to what I actually get when it comes to me in the field. So in the field, now I did the blue and the green, go back to those previous numbers so you see where I got them. I want to take that dry ton, pounds per dry ton, and convert it to wet tons. So basically I had the 101.6 pounds for Blue Plains was the pounds per dry ton of TKN. I'm just going to multiply that by the percent total solids. But again, as a decimal. So remember, if we go back, it was 101 of the digested Blue Plains dry pounds of TKN per dry ton in a dry ton, but when it comes to me in the field, it's only 30% solids. So 101 times the 30.1% solids, I'm only getting 30.6 pounds for every ton that comes to me when it comes actually in the truck. So I need to be able to, even though my permits and the lab data are all on dry weight in this, when I get it in the field, I've got to learn how to convert it so I know what I'm actually using. And again, you do that for each of the parameters. Same reference there for sod run. So that 87.8 pounds per dry ton of TKN, you know, when it comes out to me in the field, it's only 17.5% solid. So every wet ton I get in that truck only has 15.4 pounds. And roughly one of those big trucks weighs about 20 tons. You know, so I've got a truckload, now I got the wet weight, I got the weight ticket, and all that gets grabbed and calculated, and that's how we actually figure out how much, just like you would do manures. You're going to calculate how much your manure is, how much in your spreader, what it's got, and how much you're spreading. So these are kind of just, wanted to make sure when you go back and look that you can kind of see where the numbers came from. Oh, sure.
I'm sure there's a good reason for it, but why do you guys typically talk in dry tons to start?
Well, because everything is on, like all your lab data is on dry, all our permits are on dry, everything's based on, because the wet tons vary. If today's Blue Plains solids are 30, then that wet tons is whatever, but tomorrow's wet tons are 25.
So you're looking
So
at
the
a
regulated
basis.
stuff is all dry weight,
Okay.
but the real world doesn't come dry.
Yeah,
So
absolutely.
we've got to manage it on wet.
Yeah, because we usually talk manure and wet weight, you know, so I think people get picked up a little bit, you know,
Right,
when
doing
they
the
start
biosolid.
looking at the biosolid stuff, they see
Right.
the dry ton.
Well,
and
because
it
the
gets a
wet
little
weight
bit-
can change,
Yeah,
you know,
that makes
based on the
sense,
percent solids regularly.
Good point.
So typically, we manage the regulated piece of it is, it's got this much in it per dry ton, even though you get it in the wet, you gotta convert it.
Yeah, so you're looking at almost each load going
Yeah,
out,
each
and
load, we
specifically
already
what
know.
the, you know,
So we know
moisture
each load,
percentages.
and we use, like, the numbers won't change, like, so for the month of May, we're using this data, you know, we've got this lab analysis, and so for the month, we're gonna say, you know, if I go back, you know, every wet ton of Blue Plains is 30.6. That's what I'm using for the month of April. Now, the new lab might come out for, you know, for June, and it might tweak it in next month, it might be 30.9.
Okay.
Or, you know what I mean, but that's what we do, we have to change it every time we get new data.
I will
Yes, ma'am.
say also NDE reporting is all in dry weight.
Yes,
Yeah,
everything's
yeah.
dry weight.
And again, I think like a lot of times, you know, you guys are typically writing the plans, right, for the Class B. And I think it, you know, people just tend to get hicked up trying to come
Well,
up with those credits and, you know, they don't
It's
realize
definitely
they're starting
another
with dry
culture and
tons a
another
lot of
world, but
times.
again, we're
Yeah.
regulated on dry weight,
Yeah,
so
understood. Yeah.
nutrients are, and again, they give us every biosolid, and each biosolid has its own pan, and they don't change that but once a year. So the pan stays the same for the plant available nitrogen and the phosphorus and all, they give us, stays the same for that particular treatment plant for the year. Solids may change throughout as we go, we kind of change that as we go through the process. But that's the way they make us manage it. So if it says in the back of our permit, so I'll show you as we go through, but we'll do a plan. and you need 100 pounds, and the rate, came, so it's 4 dry tons, well, then we convert that 4 dry tons divided by, whatever to get, how many wet tons is that? So that's how we load the field, and we do our plan so that the farmer can have a regular plan that just says, I need 125 pounds. Then we also do like 2 tables in the back for us that says, if you're using Blue Plains, it's this. If you're using Cox Creek, it's this. And so it's all there. The plan looks kind of overwhelming, but it's because we pretty much put every scenario that we can think of, and our permits have to be pre-approved. Our NMPs have to be pre-approved. So if we forget to add a crop, we can't do it. So when we write a plan, you can see we're going to have corn, we're going to have beans, we're going to have wheat, we're going to have barley, we're going to have alfalfa, we're going to have grass hay. That farmer might grow 2 crops, but he might change his mind over a 5-year period, and if I don't have it on that permit, I can't add it to the nutrient management plan without modifying the permit. So it's an ongoing struggle. So we've learned to put the kitchen sink in there, and all the biosolid sources that are approved. Even if we don't have that job, we might have it next year. So if that permit's good for 5, I want to make sure that that permit has it if I get it. Anyway, it's definitely more than you need, but it's all there. And it is set up on the front page or 2 that a farmer can just look at nitrogen of how much he needs without the biosolids piece. So I hope that's somewhat helpful. Yeah. So anyway, I just tried to throw some of these numbers up here to just where do we fall out with other manures and things. So, Blue Plains, again, here was the 30% N. This is on wet weight again. This is wet coming out to the field. Every wet ton has this. Side on that, we got basically cattle manure, you got poultry, broilers, and then you've got the phosphorus variations. They're all over the place. So you really got to kind of look at the data, and the lab data and the units are keys to make sure you're looking at it. Is it in dry weight? Is it in wet weight? What is it? And then mineralization, remember for us too, you've got that chart in there, it'll tell you what's what. Biosolids have its own set of different mineralization factors. So again, for us, and I think we touched it a little bit, we have to write an NMP. Okay, so the MDE permit is good for 5 years, but we write an NMP when we first turn it in, and then we have to update it every year. Even if we don't apply, we have to at least update the new pan. So if MDE comes out at the end of the year, or here's 2022's new numbers, even though we didn't run in 2021, we at least have to update those, what is the new Blue Plains numbers, so that, maybe the crops didn't change, the residuals didn't change, the calculations didn't change, but that pan number did. So we have to, every year at least, update the new pan numbers. So they're basically good. We update them pretty much every year. So it's a little bit more. We have at least been able to follow some of the new nutrient management stuff. So we can use soil samples now for the 3 years like normal. Before we had to update every year, grab a new soil sample, grab a new. Now they've kind of just adopted nutrient management regs, which is somewhat helpful because farmers are going crazy. But at this point, we're following that, but we still do have to update every year. And again, we're doing exactly the same thing as any other plant. We're basically going to the farmer and saying, what are you growing? We might add a couple extra things if he thinks he might, and kind of get some historic numbers, or look at even just, yields out of the book to just put something on the plan. But we're basically looking at yield goals, figuring out, the best 3 out of 5, figuring out the crop. We're calculating how much is there that's needed for that crop, and then we're coming up with a recommendation. We have to do a lot of residual stuff, though. So for us, again, we start out with, let's say you wanted that 125 bushels of corn, we need 125 pounds. If we had manure, we got to subtract whatever manure is going to be put out. Biosolids were applied last year, or the year before, or the year before that. I got to go back. We go back 3 years for biosolids applications, and put them on the sheet as far as minusing from that 125, whatever the residuals are from the previous. Same thing like you would do if we had any soybeans in the field, for instance. And so let's say we needed that, we minus it, now we're down to, he needs 100 pounds, and we'll have that on the utility recommendation sheet on the side. And we use just a standard form. I didn't fill this one in, but we'll get to the one that is, but field acres, what he needs, what's his yield with the normal recommendations. Then we subtract out all the residuals or current year that's going to be applied. Let's say he's got residual biosolids, he's got residual manure, and he's going to actually apply manure in that field this year, and then whatever's left over is on the, what he can do for this particular program. So again, MDE gives us the pan, but I do believe you need to know how to calculate pan. So it's not as hard as it looks. So this is pretty much the formula. The big key to remember the pan is it's basically the ammonia times the volatilization, and we've got only 2 for biosolids. So if it's surface applied, it's 0.5. We're saying you're losing half of it, basically because you left it on the surface. If we incorporate, it's 1. So whatever the ammonia is, it is, you're not reducing it by half. And then you've got our mineralization. So whatever that organic nitrogen is, you're going to, if it's an aerobic in a lime state, then it's the 0.3. If it's anaerobic, it's 0.2. We've really got, in compost is 0.1, but we really are between 0.2 and 0.3. It's one of those 2 for biosolids, just to keep it brief. There's the regs, and I go through the calculation. I used the blue planes so you can see how I did it from the data that I gave you on the first sheet. So basically the ammonia, percent ammonia was 0.66. I'm going to incorporate, so the volatilization was a 1. The nitrate was 0.0025. Organic nitrogen was 1.4. I used the mineralization factor of 0.2 because it's anaerobic. And then the 20 is just a calculation factor. So the pounds per dry ton of the blue plains is 30.9. And again, this is just going over that mineralization. There's a sheet, there's only 3 of them. And so here's that number. So for us to calculate that first year pan, we use either for the aerobic and lime state is the 30%, 0.3. If it's anaerobic, it's 20%, 0.2. The 1 to 2, 2 to 3, 3 to 4, those numbers are for us, for biosolids folks, to calculate the residuals. Then I got to go back 3 years. So those are the numbers I have to do when I figure out how much I applied last year. These are the factors in the calculation to calculate our residuals for previous applications. So if I applied a lime state last year, doing the plan for this year, I've got to use that 2.1 factor when I do my residual calculations. And then whatever that residual is, I got to total them up. So last year's, the year before, and the year before, so I got to calculate 3 years back to do my residuals for biosolids. So and so basically this is just kind of a quick summary. Here's the field, we'll put multiple crops. We'll subtract out the biosolids if it had it, if it was a lagoon, the previous year stuff, and then on the final column all the way to the right is what's actually required. So that part, the farmer at least knows that for that field he needs, 116 pounds to grow that corn because he's already got 9 pounds of residual. And then our other sheets that we put behind it have all the, if you want to put these following 10 biosolids plants, it's basically taking that 116 divided by whatever the pan is, and then he gave us for corn and this. So it gives us a dry ton number for every sort, for every crop in the back. So sometimes they look at that, they'll get a little overwhelmed. If they're just trying to do their normal, what do they need, and they're not getting biosolids this year, they actually have a plan that still tells them what they need, if that makes sense. And then for phosphorus, we're all in the same boat now. Everybody's following PMT. So if the soil analysis is over 150, we're following PMT, figuring out applications, doing, 3-year crop removal, blah, 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 until we go down, or we're looking at, waiting and sampling. But we're basically doing exactly like you are doing any other plan. So nothing is different other than we update it every year. And then we calculate everything for rates for biosolids in the back. But we still get the pounds of nitrogen and phosphorus and potassium. Where to get more info, MDE, like I said, puts out the current pan every year, comes out in the fall for the next year, the regulations. If you need to know what's happened on past permits and applications where it gets a little hairy, we're trying to figure out, you're better off trying to just reach out to the contractor because the way MDE's regulations are, it's kind of annual reporting. So they might not get what I did this year if you're trying to figure something out until end of the year. It's not due until January, whatever. So, you might be waiting a little bit to get last year's stuff. Now, mind you, the farmers say they don't have it, but when we go to every field, we give them a copy of the NMP. When we leave, we tell them what we give them a handout of actually what we roughly put out. We do a hand. So when they say they don't have it, they really do. They just don't know they have it, or they put it somewhere, or they're just telling you they don't have it, but they have it. They may not understand it, but they have it. But the best thing to do is, like I said, if you're looking for past stuff, is kind of reach out to the folks. So I think that was my end. Any questions, application, however, regulation?